Hello, welcome back to Math 7 with Mr. Passon. Today we are talking about the area of rectangles and parallelograms. Area is the surface measurement of a two-dimensional figure. We use the formula area equals base times height to calculate their area, where b is the length of the base and h is the height of the rectangle. Area is measured in square units. So square feet, square inches. Inches times inches would be inches squared. So we're going to do I and 2. We're going to highlight the 2. Control period to get the superscript, get the exponent. Feet would be ft 2 and control period. And we can do m, and then we can actually even hit the control period first and then type 2, and then control period will get us back down to the original, but I want a lowercase m, so I'm going to put a little extra quote in there just to remind us. Now, what we want to talk about a little bit is what we deal with when we're multiplying by fractions. So we're going to get to that in just a bit, but our first example is going to involve a decimal, okay? So we would ask how many squares it takes to fill this up. Well, it's 3 squares this way by 8 squares, and that's going to be 3 times 8. And then this last little strip, it's going to be 3 parts of a square. So we're going to get 6/10 of a square plus 6/10 of a square plus 6/10 of a square. But we can always do that by a equals b times h. Alright, now let's plug in our values. So our a equals 8.6 times 3, so our area is 25.8, and let's look at our units. It's got to be centimeters squared. Remember control period to get the exponent. This one, well, again, we're still going to use that exact same formula. Area equals base times height, so my area equals 2 1/4 times 1 1/2. Alright, now I'm going to convert those both into fractions because I think it's a little easier to do. So I'm going to do 8 9/4 times 3 halves. And I'm going to make that box just a little bit bigger so it fits in there. Now let's go ahead and do that multiplication. 9 times 3 is 27. Oh, I just deleted something. So my area is 27 over 8. 27 over 8. Now we can convert that back into our mixed number. 8 goes into 27 3 times, and there is 3 left over. So 3 3/8 square feet. So feet, control period, 2. Now, when we're dealing with fractions, there is a couple things that we do want to pay attention to. So I'm going to pause here for a second. I'm going to pull up a little graphic, and we're going to talk about what multiplying by fractions means. Okay, so I've drawn a little rectangle here. It is 4/5 by 3/5. Okay? So let's think about it. If I wanted to fill this in, well, it's not even a full square. So when I multiply 4/5 by 3/5, it's going to take less than 1 full square. But let's see how many of these little squares it fills in. So these little squares here, it's 5 by 5. So there's 25 little squares in here. And so of those 25, this is 4 wide and 3 tall. So that's 12 25ths, which 12 25ths ends up being the exact same as 3/5 times 4/5. So our rule works even when we're multiplying fractions, but remember that when we're dealing with a part of a square, we're just going to break that square into smaller pieces. Alright? So now we can continue on. Anytime we're dealing with fractions, we're just going to multiply them like we would any other term, when we can multiply decimals just like we do any other term. Now, 2 walls in a room are being painted. Each wall measures 16 feet by 8.5 feet. How many square feet will be painted? Well, let's think about that one. I forgot to put the little box in here, so I'm going to put a little box in here. Well, we've got 2 walls, so 2 times the area of one wall, and the area of the first wall is going to be 16 times 8.5. Now, I just went ahead and converted 8.5 into a decimal because it was easy to do. If it was not easy to do, I could have left it as a fraction. Okay, so let's do 16 times 16 times 8.5, and then we will double our answer, because this is one wall, and then here is how we get our second wall. Alright? Now, I'm going to do that off screen for just a second. But we would line up our decimals, do it just like we normally do, except for I pressed the wrong button. So what we get here is we get 2 times, oh, I should put a little equal sign in there, 2 times 136. Alright, so this right here was 136. So that's going to be 272. Now let's look at our units. That's 272 square feet. Or again, we could write it as 272 ft raised to the second power. So that's shift period to get that exponent. Now, when we're dealing with formulas, formulas can be manipulated to solve for missing information. So, for example, we could go ahead and take this and solve for b and say b equals a divided by h. Or we could say h equals a divided by b. So if we took both of these sides and divided by b, we'd get a over b equals h. And if we took both sides here and divided by h, we'd get a over h equals b. Alright? So sometimes we're going to know all the information, or sometimes we're going to know the area, and we're going to go back and try to find the missing side. This is why we practiced equations earlier in the year. So we know that our area equals base times height. Our area is 162, and that's going to equal our base times 18. Well, how do we solve this? Divide both sides by 18. So we have to do 162 divided by 18. And that works out to be 9. So we get 9 equals b, or b equals 9. And we had meters squared divided by meters, so that's going to be meters. Alright, now we had the work theoretically showed over here, but I just did it over here. Same thing. Alright. Cool. Go ahead and go on to page 2. Now, turns out we've got a couple of word problems here, so we're going to go ahead and try to solve those. A rectangular canvas covers 225 square inches of wall. The canvas has a height of 18 inches. Now, I think in general it's a really good idea to draw the shape. So if I'm drawing a rectangle, I'm actually just going to drop a text box in here because that's already a rectangle. And I'm thinking, oh, the height is 18, so 18h. 18. And I'm going to drop that size down, make this not adjust automatically. And make sure it has a nice thick border so it's clear that it's my drawing. Alright, now, so we know our area equals base times height. And we can say our area is 225. And that is going to equal base times 18. Well, how are we going to solve that? Divide both sides by 18, right? That's the opposite of multiplication. So we do 225 divided by 18, and b times 18 divided by 18. And we get that 12.5 equals our base. So our base is 12.5 inches. Alright, let's look at this one. Circle all the formulas below that could be used to find the height of a rectangle with a base of 11 inches and an area of 120 inches. So we know area equals base times height. So hey, here's the one where area equals 11 times 11. That's not true. Area equals our base times our height. Hey, looks like there is an answer. So what I'm going to do is over this A, I'm just going to put a few X's. It doesn't work. Let's check this B. Well, it's the area is the 120, so that one's not going to work. Let's look at this C. Area equals base times height, which means height equals, oh, it looks like C is the first step and D is the second step. But this one, E, does not make sense. So in my case, it's C and D. Now, if I grab my shape tool, I can even put a little ellipse around it. Circle it, just like they said. There's my circle tool. That one. Oh, except for, real quick detail, fill you want transparent so you can see. I'm going to copy that circle and put it there. Cool. Now maybe I should remove the background of this one, just so that way we can see what we've crossed out and what works. And there we are. Now, we're most of the way done, because turns out parallelograms actually are just like rectangles. I'm going to pause for a second. We're going to see why. So again, I'm going to switch over. We're going to do a real quick exploration of why, and then we're going to come back to this. Okay, so if I look at a parallelogram, and I look at the left-hand side, and I draw a vertical line, and I'm going to call that side the height, and then I come over here to this side and draw another vertical line, you can see that in fact this triangle right here, and I'm going to make that triangle a slightly different color just so it's a little easier to see. Maybe. Oh, I need to edit first. Oh, no, that worked. Good. So we can see that this triangle would exactly fill up this space and turn this into a rectangle. So we can use the exact same formula for area of a parallelogram as we can for the area of a rectangle. Okay? So if we take advantage of that, right, and we're going to look at then the dimensions of a parallelogram are also referred to as the base and the height, and the formula is still area equals base times height, where here base is the length along the base and h is the height of the parallelogram, not the length of the angled side. Again, let's pay attention. The height is here. The height has got to be perpendicular to the base, meaning at 90 degrees to. Whereas this is just a side length. So we need this length here and this height here, the perpendicular direction to, or perpendicular to the base. Okay? Now, and we said that was a right angle with the base. And again, I'm going to make that just a little bit longer so that way it fits in our box. So notice we're not actually going to use this 10 centimeters at all because it is not perpendicular to our base. Here's our base and here's our dimension that is perpendicular. So for us, our formula is area equals base times height. We want to put in our numbers, which is 12.2 times 8. We do that calculation real quick. And we get then that our area is 97.6 square centimeters. This one, again, we're going to use our area equals base times height. let's put in our area equals 6 times 2.5. Okay, again, I'm just going to convert it to a decimal because it's easier to write for me here. Or you could have written it equals 6 times 5 over 2, which is actually easier to do in my head, so I'm going to do it that way. So 5 times 6 is 30, divided by 2 is 15, so 15 square feet. Okay? Now, describe how the area of a rectangle and the area of a parallelogram with the same dimensions are related. They have the same area. Alright, if they have the same base and height. Alright, now, the dimensions that we're talking about are the base and the height. There are lots of parallelograms with the same base and height that are actually different parallelograms. So if I stretched one end of this further, so I went 15 on top, I'm going to draw another parallelogram. Oh, I forgot I have to click and let go. 1, 2, 3. So this parallelogram, let me finish it. This parallelogram and this parallelogram, they both have, 3 for a base and 1 for a height. So these both have area 3, but they look very different. So as long as they have the same base and the same height, we're going to say that they have the same area, no matter how skewed or how sort of stretched out in one direction, or I guess not stretched out, but sheared in one direction it is. So again, look, this one has a height 1 and a base of 3, so it's the same as this one that has a height 1 and a base of 3. Okay? So these two have the same area. Okay, add a box to summarize what you learned. Go ahead and practice for your assignment in ALEKS. Thank you for coming today. I hope you have a great day, and I will see you next time.